So, types of lines, that's the heading today. Types of lines. And in types of lines, there are four types. The first one is coincident. Okay, coincident line. So, what do I mean by this? Well, coincident line means you can have different vector equations for the same line. இல்லையா? So, that's possible. And those equations will represent the same line, and that line will be considered. Those lines will be considered as coincident lines. So, let's say this is AB, okay, and let's say this is BC, where BC and AB are coincident lines. That's the idea here. Okay, that's one. Second one, parallel line. Okay, next one is parallel line. I don't think you need a explanation for parallel lines because we know what are parallel lines here. If two lines are parallel to each other, or it can be in another direction, okay? It can be opposite to this, but still they are parallel lines. It can be in the same direction or the opposite direction, but they are still parallel lines. And then we have the third type, okay? And then we have the third type, which is called intersecting lines. Okay, intersecting lines. So intersecting lines are lines which intersect at a specific point. Okay, lines that intersect at a specific point. This is what we call intersecting lines. Okay, they are definitely not parallel and they will be intersecting. Fourth and important one is skew line. Okay, so this is the new thing that you have to keep in mind. What are skew lines? Well, skew lines are not parallel to each other, but still they don't intersect. Okay, just think of this. Okay, let's say we have two lines like this. This may look like they are intersecting. Okay, this may look like intersecting, but when you are looking from this perspective, okay, when you are looking at this perspective, it looks like this. Okay, this is a specific plane. Okay, this is a specific plane, and this is a specific plane. Okay, this is a specific plane. Okay, and if this is line L and if this is L2, okay, let's say this is L1 and L2, L1 will go like this and L2 will go like this. When you're looking in this direction, okay, when you're looking in this direction, around in the direction, when you're looking at this direction, it may look like they are intersecting, but actually there is a gap between them. Okay, there is a gap between them. These are what we call skew lines. Okay, now we have to learn. Okay, this is the introduction. Now we will learn how to prove these lines. I am going to start with parallel lines. Okay, I'm going to start with parallel lines. I'm going to start with parallel lines. How can we find parallel lines? Okay, let's say there is a line L, L1, and there is another line L2. Okay, let's say there is a line L1 and there is a line L2. Let's say L1 is given as R is equal to, obviously, the vector equation. R is equal to A plus lambda B, and L2 is given as R is equal to C plus mu C, mu D. Okay, C plus mu D. Well, they are vectors. How can you say if these two lines are parallel? Well, consider this. Look at the direction of this L1. Okay, consider the direction of L1. We can see the direction of L1 is like this, and the direction of L2 is kind of like this. Okay, but the thing is, if these two directions are parallel to each other, if these two directions are parallel to each other, we can definitely say L1 is parallel to L2. Okay, so what is the direction here? Well, we have the direction vector in each line. Okay, so if you can prove B is parallel to D, well, then you can definitely say L1 is parallel to L2. This is the idea. This is how you can prove parallel lines. Okay, so how can you prove that direction vector, not a direction vector, how can you prove two direction vectors are parallel to each other? Simple. If B is equal to KD or D is equal to KD, okay, well then their K is a real number. Okay, well then you can say B is parallel to D or D is parallel to K, D is parallel to B, vice versa. So let's do a question to quickly understand what I mean by this. Well, to prove that L1 and L2 are parallel to each other, to prove that L1 and L2 are parallel to each other, we are going to do, we are going to find the direction vectors of L1 and L2. Okay, so direction vector of L1, okay, B can be given as 5, 10, 15. Okay, this is what I am writing in the numerical form. And similarly, I can write this down, okay, as maybe B is equals to 1, 2, 3. And this can be given as a multiple. Yeah, this can be given as a multiple of D. So I can prove that B is equals to 5D. Okay, therefore, I can say B is parallel to D, which means L1 is parallel to L2. End of discussion. Okay, now we are going to understand coincident lines. Okay, coincident lines. Okay, coincident lines. Well, this is pretty easy. You can prove if two lines are coincident. Uh, you can prove if two lines are coincident if they are parallel and if they have a common point between them. Okay, so if L1 is same as L2, okay, if L1 is same as L2, what you have to prove is L1 parallel to L2 and a specific point. Okay, they have a common point. If they have a common point, L1 and L2 share a common point. L2 share a common point. If you can prove that, if you can prove that, you can say they are coincident. Okay, I'll give you an example to easily understand. Okay, well now, first of all, you have to prove L1 is parallel to L2. For that, you have to prove the direction vectors are parallel to each other. So the direction vector here can be given as B is equals to 2, 3, 4. So you can say let B equals to 2, 3, 4. Okay, and let B equals to 1 comma 1.5 comma 2. Okay, and you can say B is equals to 2D. You can multiply and see, so which means B is parallel to D, which implies, okay, which implies L1 is parallel to L2. Now you have to only prove that they share a common point. Well, that's also easy. Why is it easy? I can write the parametric equations of L1 and find the lambda where the parametric equations support 11, 17, and 23. If they support these values, well, bingo. Okay, yes, they are coincident. If we don't find a single value for lambda, okay, single value for lambda, well then, yeah, we can say they are not coincident, they are just parallel. Okay, so let's do that. So for L1, okay, and I have to prove if 1 plus 2 lambda is equals to 11 and 2 plus 3 lambda is equals to 17 and 3 plus 4 lambda is equals to 23. Okay, so first of all, let's say 11 is equals to 1 plus 2 lambda. I'm jumping here and there. So first of all, this is step 1. Okay, this is step 1. Okay, this is step 1. Okay, this is step 1. So this is step 1. And this one we have step 2. This is step 2. So let's name these equations 1, 2, and 3. Let's name this as step 1. Okay. So now we are going to step 3. All right. 7 is equals to 1 plus 2 lambda. So lambda will be equals to 5. Sub lambda is equals to 5 in 2 and 3. You can change the orders. You can start with 2 or you can start with 3. I normally do with 1 because that's conventionally easy for me. So 2 states that 2 plus 3 into 5 is equal to 17. And fortunately, that is equal to the y coordinate, the point vector of y coordinate of point vector of L2. And similarly, if I sub in 3, that states that 3 plus 4 into 5, which is equal to 23. Surprise, surprise, they also verify each other. Okay, therefore, we can definitely say L1 is parallel to L2, L1 and L2 share a common point. Therefore, they are coincident. They are coincident. Okay, very simple. Very simple. You can do that by writing some more lines if you want. Okay. Now let's talk about intersecting lines. Okay. Now let's talk about intersecting lines. Okay. So for intersecting lines, it's simple. It's very simple. I'll write the heading first. Intersecting lines. Intersecting lines are actually very simple. You don't even have to prove they are not parallel. Okay, you just have to check whether the values can be replaced with each other. If they two share These two lines share a common point. That's all. You have to find if they share a common point. That's the gist of it. Okay. How can we do that? You just have to make sure these two lines have a common point. That's all. Right. Now let's do that. So L1 is given as this. So first of all, let's write the parametric equations. Similarly here, okay, so this is the parametric equation. Now we have to equate this. Okay, now we have to equate this, which states 1 plus 2 lambda is equals to 3 minus mu. If there was a common point, if there was a common point, 1 plus 2 lambda will be equals to 3 minus mu, and 3 minus lambda will be equals to 1 plus 2 mu, and 2 plus lambda will be equals to minus 1 plus 5.5 mu. If there was a point between these two lines, completely shared with it. Okay, so now I can make them into simultaneous equations. Okay, I can change them into simultaneous equations. How can I do that? Well, in this case, mu is equal to 3 minus 1 minus 2 lambda, which means it is equal to 3 minus 2 lambda. Okay, and here I can change lambda is equal to 2 and 2 minus 2 mu. Okay, so that is equals to 2 minus 2 mu. Why did I write 3 here? I don't know. Okay, it must be 2. Okay, that's it. Now I can replace this. This is the first equation that I derived finally. So that is second equation. So by using this, I can find actually mu or lambda. I'm going to replace mu with lambda. So if I replace that in first equation, okay, actually wait, what is easier? Yeah, so I'll replace mu equals to 2 minus 2 lambda in second equation. Okay, so lambda is equals to 2 minus 2 into 2 minus 2 lambda. So that is equals to 2 minus 4 plus 4 lambda. Yeah, so lambda is equals to, so that will be 3 lambda equals to negative 2. Okay, so am I correct? Am I doing it right? Minus 4, so this is minus 2. So when I bring minus 2 here, it will be plus 2. Yeah. So lambda is equals to 2 by 3. Okay. So lambda is equals to 2 by 3. Now I can replace that to find the mu. So mu is equals to 2 minus 2 into 2 by 3, which is equals to 2 minus 403, which is also equals to 203. Nice. So mu is equals to lambda is equals to 203. That's what we got. Well, we can't stop here. We have to verify. That's where third equation comes to play. So in third equation, LHS states that 2 plus lambda. So 2 plus lambda is equal to 2 plus 2 over 3. So that is equal to 8 over 3. And right hand side suggests that it is equal to minus 1 plus 5.5 mu, which is simply 11 over 2. Okay, I'll just write it. 2. It's better. Into 2 over 3. Why? Mu is equal to 2 over 3. So 2 cancel, and I will get what? Minus 3 plus 11 over 3, which is equal to 8 over 3. LHS is equal to RHS, so verified. So we have a common point, and that's when lambda or mu is equal to 2 over 3. Okay, and now you will replace this. You will replace those. Replace those things. Okay, you will replace those. How? Well, the common point. Okay, or the intersecting point. Instead of saying common point, we can say intersecting point. Intersecting point. Intersecting point can be given as, intersecting point can be given as yeah, 1 plus 2 over 3 into 4, comma 3 plus minus 1 into 2 over 3, comma 2 plus 2 over 3. How did I come up with that? Well, this is 1 plus 2 lambda, so 1 plus, why did I then put 4? It's 2. Yeah, it's 2. 3 plus, similarly 3 plus minus 1 into 2 over 3, 2 plus 2 plus 1 into 2 over 3. So that is equals to 4 7 over 3 comma minus 2, so 3, so it's also 7 over 3. Wow, that's also a coincidence. 2 6 8 over 3. That's all. Very simple. So this is the intersecting point. This is how you have to verify if two lines are intersecting or not. Well, Q lines, there won't be intersecting lines. In this step, LHS won't be equal to RHS. Then you can say they are not intersecting lines. But you have to make sure the lines are not parallel to each other. Okay. If they are parallel also, they will not intersect. Yeah. So you have to make sure they are not parallel. At the same time, there is no intersecting point. Well, let's try one. Q line. Q line. What do you have to do? No intersection. I mean no intersecting point, which means no common point. Okay, no intersecting point. As well as we don't we surely know these lines are not parallel. Lines are not parallel. Very important. Keep in mind. Okay, because when we will be learning about three planes. Okay, the intersection of three planes, there can be skew plane. Okay, okay, fine. So I'll give an example. Okay, you can definitely say L1 is not parallel to L2. L1 is not parallel to L2. Why? Why is that? Well, in the direction vectors. Okay, here we have 1 to 1, and we definitely know this is not a multiple of 1 to 1. Why? To form minus 2 from 1, you have to multiply by minus 2. If you multiply by minus 2, you will get minus 2 here. But 2 into minus 2 is equal to minus 4. So that's not equal to each other. So they are not parallel. Now we have to show they don't have an intersecting point. We'll do the same drill. Okay, we will continue the same drill. It means we have to now equate each other. So if there was an intersection point, 1 plus lambda will be equals to 4 minus 2 mu. 2 plus 2 lambda will be equals to minus 1 plus mu. And 3 plus lambda is equals to 2 plus 3 mu. Price. And now how can we find this? Well, we have to come up with equations here. So lambda is equal to 3 minus 2 mu. So this will be the first equation. And in the second equation, mu is equal to 3 plus 2 lambda. That is the second equation. I'm going to sub lambda is equal to 3 minus 2 mu in second equation. So that will give me mu equals to 3 plus 2 into 3 minus 2 mu, and mu is equal to 3 plus 6 minus 4 mu. So when I bring 4 mu this side, that will be 5 mu. 5 mu equals to 9. So mu is equals to 9 over 5. And we know lambda is equal to 3 minus 2 mu. So lambda is equal to 3 minus 2 into 9 over 5, which is equal to 15 minus 18 minus 3. So minus 3 over 5. Now we have to verify for third equation. So for the third equation, LHS is equal to 3 plus lambda, which is 3 plus, okay, 3 plus minus 3 over 5 means 3 minus 3 over 5. Yeah. So that is equal to 12 over 5. And now RHS is equal to 2 plus 3 mu, and 2 plus 3 mu is equal to 27 over 5, which is 29 over 5. So LHS is not equal to RHS. It implies there is no intersecting point. L1 and L2 don't have a common point. Don't have a common point. Therefore, therefore, they are skew lines. They are skewed. Yeah. So this is it. The summary is parallel lines to prove that two lines are parallel to each other. What you have to show is the direction vector is equal. The direction vectors are parallel. If they are intersecting lines, you have to just take their parametric equation, and that's it. Okay, you have to take their parametric equations and equate them to find the parametric value that supports the common point. And for same line, okay, you just have to prove the vectors are parallel to each other. The direction vectors are parallel to each other, and there is a common point. And for skew line, okay, and for skew line, you just have to show that they are not parallel at the same time. They don't have an intersecting point. Very easy, very conceptual. So keep this in mind because this will be useful when we are studying the application of vectors. and we are studying the application of vectors, where we will be practicing questions based on the path, the crossing paths, or whether they will meet each other, etc., etc. Keep that in mind. Okay, I'll see you in the next video. Yeah, sure.
Thanks for watching the 16th video in our vector series. If you found this explanation of the types of lines in vector geometry helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and don't forget to follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.